All right, welcome back. Dr. Pitcher here, and in this lecture, I want to summarize isomerism, or what we've seen so far. So I like to do this by making a flow chart. So we can start with isomers. And isomers have same chemical formula, but different structures. Now, there are two types of isomers that we've seen. Back in chapters 3 and 4, we looked at constitutional isomers. And constitutional isomers have different connectivity. That is, the atoms are connected differently. So, for example, I could look at cyclohexane and compare that to methyl cyclopentane. These are both C6H12, but the atoms are connected in a different order. Now, on the other side here, we have stereoisomers. And stereoisomers have the same connectivity. But there's a different three-dimensional, so 3D, arrangement of atoms. And among stereoisomers, we have two different kinds. We have diastereomers. I do apologize if there's a phone ringing in the background. I've had to relocate my office to the dining room. We have diastereomers, and then the other are stereoisomers. Not stereoisomers. God damn it, Wayne. All right, enantiomers. Sorry, I got totally thrown off by the phone ringing. There we go. Enantiomers. So diastereomers are non-superimposable, non-mirror image isomers. Enantiomers are non-superimposable, mirror image isomers. Sorry for squeezing that in there. Isomers. So we've seen, for example, we could have, well, let's just do this. 1, 2, 3, 4, 5. There's a hydrogen hiding back there versus 1, 2, 3, 4, 5. Hydrogen in front OH in the back. So that carbon is chiral. It's got a hydrogen, a methyl, an OH, and then a propyl group on it. So four different things. Here we have those same four different things, but now the H and OH are switched. So these are going to be enantiomers. That's another little helpful thing. If you have one chiral carbon and you switch the configuration, or you switch two groups, you will get the enantiomer. I'll summarize that on the next page. Oh, I do apologize for some of the background noise. One of my kids is taking the dog for a walk. So, now diastereomers, we can have cis and trans isomers. So these would be things like trans 2-butene versus cis 2-butene. Versus there. And then we'll have other diastereomers. More than one chiral carbon. And so an example here could be something like, let's see, well, I can just draw my Fisher projections. You don't have to draw Fisher projections if you're going to draw some diastereomers. But it can help. So I'll change the configuration there, but not there. So now I've got my diastereomers. Okay, and this is important. So if I made the enantiomer, I would change the configuration at both carbons. But since I haven't made the enantiomer, I've made a diastereomer, I've only changed the configuration at one carbon. And we can actually see that if we go back and take a look at the previous lecture, which I'll do in just a minute. But let me just kind of center this so you guys can take a good look at that, copy this down, take a screenshot. There's a similar flow chart in figure 5.15, but it doesn't have examples. So I like this sort of just as a general summary. Okay, so let me show you some tips and tricks here. Let me get a new piece of paper. Other pieces are just giving me something comfy to write on. So Dr. P's stereoisomer tips and tricks. Okay, so for molecules with one chiral carbon, switching two groups makes an enantiomer. So if I have these guys here, so I've got my mirror images, they're non-superimposable. If I switch two groups, switch my hydrogen and my bromine, or stubborn bromine, well now these are not mirror, they're no longer mirror images, but they are superimposable. Everything lines up. So they are the same thing. And all I did was I switched two groups. If I switch two groups again, I'd go back to the original molecule. So if I started with this, I switch two groups, I'd make the enantiomer. If I start with the enantiomer and switch two groups, I'd make the original molecule. Okay. Now for molecules with more than one chiral carbon, must change configuration at all chiral carbons to make an enantiomer. Changing at some chiral carbons makes diastereomers. Let's look at an example of that. So let's say I had, excuse me, let's say I had the following molecule. So let me go ahead and draw this here. And actually I'll do a couple of examples. So let me do one, and I'll have maybe I'll make a Fisher projection here. I'll have three, I'll do some kind of sugar here with three H2OH. And if I go ahead and switch two groups, that changes the configuration. So I've switched those two groups, but I also have to switch those two groups and then switch those two groups. So all three carbons have configurations switched. And that's going to give us the enantiomer. If I had only, let's say I switched at, I switched the first one, and I switched the second one, but not the third one, so the configuration is not switched here. That's going to be a diastereomer. Again, there's only ever one enantiomer for a given compound with multiple chiral carbons. Everything else, all the other stereoisomers, are going to be diastereomers. We could look at another example here. Let's do this. Let's make a ring, and on this ring I'm going to stick a CH3, and then I'll stick an OH and an NH2. And I'm going to have to change my configuration at all of these. 3OH and H2 to make the enantiomer. I'll just abbreviate that enan. If I kept one the same, or more than one the same, so let's say I kept the methyl the same, but I switched the OH and the NH2, that's a diastereomer. If I kept the configuration the same at methyl and OH, but I switched to NH2. That's also a diastereomer. So there's a bunch of diastereomers. In fact, with 3 chiral carbons, we should have n to the 3 stereoisomers. So that's 8 stereoisomers. We'll have our original. We'll have the enantiomer. And then the other 6 are all diastereomers of those first 2. All right. Now, as you guys are working on the practice problems, I'm sure questions will come up, so feel free to ask. You can obviously email me or wait until we meet in person on Friday or even in lab and go ahead and ask. And if some more tips and tricks pop up, I will let you know and I'll write them down for you. All right. Okay, well, until next time then, stay safe out there. Bye now.